Okay, so today's lesson, we are looking at the slope of lines, slope of line segments. So when we talk about slope, we are looking at the steepness of a line segment. So the first method you can use is counting the units when you look at a graph. So we look at the rise over the run. So when we talk about the rise, we're talking about vertical. Okay, so vertical, up and down. And when we're talking about the run, we're talking about horizontal. So horizontal length and vertical height. All right, so let's take a look at these graphs here. And another important note is we're looking from left to right when we look at our lines. And if we're counting our rise and it's positive, that means we've counted up. If you count down, then it means it's negative. And it'll make more sense when we look at the example. As well, when we're looking at our horizontal length, when we're counting our run, we are looking at counting from left to right. And it's going to be positive if we count right, and it'll be negative if we count left. So let's take a look at our line segments here. Let's look at AB first. So first of all, we're counting from left to right. So here is A and here is B. So the first thing to note here is the line is going upwards. All right, so any line that goes upwards from left to right, we know it's got a positive slope. So now let's count our rise first. So our rise is from point A to point B, and we're counting up 1, 2. So our rise is therefore 2. So let's look at our rise here. AB, our rise is 2. And next, let's count our run. Our run is our horizontal length. So from A to B, we have 1, 2, 3, 4, 5, 6, 7 to get to B. All right, so again, it's rise over run. Rise over run, so rise divided by run. So our rise was 2 and our run is 7. So our slope is 2 over 7 as a fraction. All right, let's take a look at our next line segment, C to D. C to D. All right, so because this line segment we are looking at from left to right, the line is going up. All right, the only difference is that if you're going from C to D, the rise is shown as negative. But I always recommend when you're looking at your slope, always go from left to right. So left to right, our line is going up. So therefore, our slope should be positive. So counting our rise, we have 1, 2, 3, 4, 5. Our rise is 5 units. So again, from C to D, 1, 2, 3, 4, 5. So 5 units for our rise. It's showing here as -5 because we're looking at from C to D. Next is our run. Again, from C to D, we're going left, so it shows as a -4. 1, 2, 3, 4. But when we look at our rise over run, -5 divided by -4, we do end up with a positive. All right, so important, whenever you're looking at your lines, go from left to right. If the line is going up, you know your slope should be positive. All right, our next line segment is E to F. So from E to F, left to right, our line is going down. So knowing that our line is going down, we know that our slope should be negative. So counting from E to F, we're counting down 1, 2, 3, 4, 5. That is our rise. Our rise is -5. Our horizontal from E to F, we're going right. It is 1, 2, 3. So our run is 3. So our slope, again, is rise over run. So -5 over 3, that is our slope. So what we should summarize here for our slopes is anytime a line is going from left to right and the line is going upwards, like D, C, and A, B, our slope will be positive. Anytime we look at a line segment from left to right and the line is going down, our slope will be negative. All right, and our rise, we always look at our vertical height, and the run is the horizontal distance. Okay, so let's take a look at this next investigation. We have a line and we have points on the line. So it's one line, but we have the points here A, we have a point B, we have a point C, and we have a point D, but they're all on the same line. So if we calculate our slope for each of these points, what we're going to notice is the slope is the same. All right, so any 2 points on a line, you will get the same slope. So from A to B, our rise is 2 and our run is 3. 1, 2, 3. So our slope is 2 over 3. If we look at A to C, our rise is 8. 1, 2, 3, 4, 5, 6, 7, 8. And our run is 12. Okay, if you reduce 8 over 12, you still end up with 2 over 3. So the slope is still the same. Point A to D, same thing. Count your rise, count your run. Our rise is 10. Our run is 15. Therefore, our slope is 10 over 15. And rise over run, once you reduce that, it's still 2 over 3. All right, so the only thing we were investigating in this investigation is any points on that same line, the slope will always be the same. All right, next we're going to look at vertical lines here on grid 2 and horizontal lines here. So how are we going to determine slopes when there is no slope? Horizontal lines, there's no slope. Going from left to right for all of these lines, there is no slope. So we say the slope is 0. So anytime a line is just horizontal, the slope is 0. However, it's different when we have vertical lines. All right, vertical lines, again, when we look at rise over run, there is no run. There is no horizontal distance. And anytime you divide by 0, that always equals to undefined. So anytime you have a vertical line, the slope is just called undefined. All right, so horizontal line segments have a slope of 0, and vertical line segments have an undefined slope. Okay, any questions on horizontal or vertical lines? Okay, so let's take a look at grid 1 and grid 2. Recall rise is positive if we count up, negative if we count down, but we also know that if any time we have a line from left to right going up, our slope should be positive. So let's look at line 1. There's 2 points here shown on the line 1. Let's calculate our slope by rise over run. So our rise is 2, 1, 2, and our run here is 3, 1, 2, 3. So our slope for line 1 is 2 over 3. Line 2, our rise is 1, 2, 3, 4, 5. Our rise is 5, and our run is 2, 1 and 2. So our slope is 5 over 2. And then line number 3, we have our rise is just 1, and then our run is 1, 2, 3. So our slope is 1 over 3. So what we are looking at the pattern here is all of these lines that go up from left to right, they all have a positive slope. Let's look at our lines on grid 2. Notice they're all going down. All of these lines are going down from left to right. So when we calculate our rise over run here, our rise, because we're counting down, 1, 2, we use that as a negative. So our rise is negative 2, our run is 1, 2, 3, so our slope is negative 2 over 3. Line number 5, again, it's going down. So counting down 1, 2, 3, 4, 5. So -5 for our rise, and our run is over 2. So -5 over 2 is the slope. And the last one, line 6, here as well, it's going down. Our rise is just 1, so -1. And then going over to the right, 1, 2, 3. Our run is 3. So our slope is a -1 over 3. All right, so our next example here, what we know from this example, and again, this is example number 3 from lesson 4. We have a line segment that's passing through a point, -4, 2. So what we can do is plot that point. So -4, 1, 2, 3, 4, up 2. That's where the point is. And what we know about this line as well is that it has a slope of -2, 3. So that means our rise is -2, meaning going down, and our run is +3. So we can draw a line knowing just those two facts about this line segment. All right, so we would go down 2 over 3. There you get another point. You can go down 2 over 3. You get another point. And you can keep doing this, down 2 over 3. 1, 2, 3, and you have enough points now to get your line segment. And then you can connect your line using a ruler. All right, so once you have a point given to you as well as the slope, you are able to sketch the graph of that line. And just put arrows on the ends to show that that line continues on indefinitely. All right, any questions on that example? Are given, in this next example, we are given that a line segment has a slope of -5 over 7. So the slope is given to us, it's -5 over 7, and a rise of 12. All right, so we've given our slope and we're given our rise. What we need to find is calculate our run. All right, so we know our formula for slope. Slope is equal to the rise over the run. All right, so if we know our slope is -5 over 7. And we know our rise is 12, and we need to solve for run. Okay, so you can solve for the run by cross multiplication. 7 times 12, divide by -5. All right, so you can just put that into your calculator. It depends if the answer we're looking for is in decimal value or an exact value. Because the question is asking for it to be in exact value, you can leave it as 84 over 5, and it's negative. And if you do put it as a decimal answer, 84 divided by -5, -16.8. All right, but normally we are leaving it as an exact value. So -84 over 5 would be the run. Okay, any questions on how we solved for that? Okay, so we have looked at the slope using rise over run, but we can also figure out slope using the slope formula. So the slope formula is given with a lowercase m. Lowercase m represents slope. last class when we looked at capital M, that represented midpoint. So lowercase m, our rise is y2 minus y1, and our run is x2 minus x1. All right, so notice our rise, it's still our y values, which represent the vertical, and our run is the x values, which represent the horizontal distance. So let's take a look at an example using the slope formula. Okay, so let's say we have to find the slope of a line, and we know it passes through these 2 points. So points G, which is -3 and 8, and the other point is H, which is going through 7, -2. Okay, so those are the 2 points that our line is going through, and we have to figure out the slope. All right, so we're going to use our slope formula. y2 minus y1 over x2 minus x1. All right, if you're using these points as x1, y1, then make sure you're consistent, that this is x2 and y2. So just be consistent when you are putting these values into the formula. All right, so I'm going to use HG. So I'm going to change my formula just to show which points I'm using. So I'm going to use y of h minus y of g. And therefore, when I calculate x, I'm going to use x of h minus x of g. All right, if you switch them, that's okay, but make sure you're consistent. So if you changed it to yg minus yh, then you would have to use xg minus xh. All right, so I'm just gonna put in the points here. So my y value for h is -2 minus my y value for g is 8. And then my x value for h is 7. And my x value for g is -3. Okay, so -2 minus 8, and then 7 minus -3, which just becomes 7 plus 3. All right, you can put that into your calculator, and we end up with -10 over 10, which gives me a slope of -1. -1 over 1. So basically your rise is -1, or going down 1, and then your run is going over 1. Also, noting here that our slope is negative, we would know that this line is going down when we look at it from left to right. All right, so in this example, we have the points E at 15, 8, and we have the point F at -10 and 6. And 3 students have been trying to calculate the slope, but they've been making a mistake. So let's take a look at Eleanor first. So she chose -10 minus 15. So -10 is an x value here, and so is 15. All right, the top here represents rise. You would not use the x values. You would use your y values. Subtract your y values. So her mistake is that she used the x values here for rise. Next, let's look at Bonnie. So Bonnie is calculating the slope. So she used 6 minus 8. That is correct. So she used f minus e. So 6 minus 8 to calculate rise. But then she used e minus f. So she used 15 minus -10. So her mistake is she mixed up her points. She used f minus e here, and then she used e minus f for the run. All right, so that's her mistake. Next, let's look at Carl. Carl subtracted E minus F, and so he used 8 minus 6, which is correct. He can use 8 minus 6 if he's using E minus F. And then he used 15 minus 10, 15 minus negative 10. So that's his mistake. He should have put here 15 minus negative 10. All right, so let's figure out the correct slope for this line. And we'll use our slope formula, and we're going to use it correctly. So the 2 points we are looking at is E, which is 15 and 8, and our second point is F, which is negative 10 and 6. So to correctly do this, you have to choose which points you're going to use, which way you're going to use them. All right, so I'm going to go ahead and correct and solve for slope, and I'm going to use F minus E. So I'm going to say 6 minus 8. So F minus E, I use my Y values first, so 6 minus 8. And then my X values, I'm going to use negative 10 minus 15. All right, so I used FE. So I'm just going to make a note of it there that I used FE. All right, so 6 minus 8, that gives me negative 2. And then negative 10 minus 25. I'm just going to put that in my calculator. That gives me, negative 10 minus 15 is negative 25. All right, so the last thing we have to look at in this, looking at slopes, is something called collinear points. So if we look at this line here, PQR, we know that it's a straight line, and the points PQR are all on that same line. So when you have points that lie on the same straight line, they're said to be collinear. So therefore, point P, Q, and R are said to be collinear. So we already looked at an investigation for that when we looked at our slopes. So the slope of PQ would be the same as the slope of Q to R, and the slope would be the same for P to R. All right, so our slopes would be the same. So slope of PQ would equal the slope of QR, and the slope would equal PR. Okay, if you get a question like this, you just have to prove that 2 out of the 3 slopes are equal to prove that all 3 points are collinear. So let's take a look at our example for that. We have the points, we have 3 points, and we have to show that they are collinear. So we have point A at 5, negative 3, and we have point B at 2, 6, and we have point C at negative 7, 33. So we have to prove that all 3 points are on the same line. So all we have to do is calculate our slopes. So let's calculate the slope of AB. Okay, so calculating the slope of AB, I'm going to use 6 minus negative 3. And then for my X value, I'm going to use 2 minus 5. And again, you can go the other way, just make sure it's consistent. So this gives me positive 9 over negative 3. 9 over negative 3, that gives me a slope of negative 3. All right, next let's calculate the slope of BC. So the slope of BC, I can use 33 minus 6 for my rise or my Y values, and then negative 7 minus 2. for the x values. All right, so 33 minus 6, that's 27. And then negative 7 minus 2, that's negative 9. 27 divided by negative 9 is negative 3. So because we got the same slope, we've already proved that the 3 points are collinear. However, if you wanted to take it a step ahead, one more step, and you wanted to calculate your slope of A and C, you can. Slope of AC, I'll go the other way this time. I'll go negative 3 minus 33. And then for x, I'm going to say 5 minus negative 7. That gives me negative 36 over 12. And negative 36 over 12, that's still negative 3. All right, so all three slopes are the same. So therefore, we would say A, B, and C are collinear. All right, last part to this question is they bring in another point. They bring in point D, and they say find the value of y if the point D negative 4y is also on the same line segment of AC. All right, so we have to figure out what would our value of y be. Well, we already know our slope value, which is negative 3, so we can calculate the value for y using that. All right, so I'm going to use slope, and of AD, we know it's negative 3. So I'm using point A, or point A is 5, negative 3. I'm just going to make a note of that here, that I'm using point A, which is 5, negative 3. You could have used any point. Okay, so using this, D and A, y minus negative 3, which becomes y. Y minus negative 3 becomes y plus 3. And then negative 4 minus 5 is our run, and it is equal to negative 3. All right, so I'm just going to move this over here. So we get y plus 3 over negative 4 minus 5 is negative 9 is equal to negative 3. And we have to solve for y. So I'm going to multiply both sides by negative 9. That gives me y plus 3 is equal to 27. Then I subtract 3 on both sides, and that gives me, I'm just going to show that, y is equal to 24.